Sorry, there was some disruptions, and so I kind of messed up. um, and let's see. So what I was saying is that on a calculator, what you're gonna do is you're going to press this index right here. You're gonna press the log button divided by the base, which is 16, and then the log button, and then equal, and that's gonna give you the answer. In decimal form, of course, it's gonna be 2 as well, right? So let me write. I'm not gonna write every button, but first you're gonna press in the calculator the 256, and that's for this calculator. Because if you recall from the previous lesson, the one that I had was a different calculator, and I'm gonna, so that you can see it again in this video, I'm gonna use the other calculator as well. So you press the 256, which is the fixed value. You press the log button. You press the division button, then the base, which is 16, and then the log button, and finally the equal. Okay, that's gonna give you the answer, and it means that 16 to the second power is gonna be 256. Okay, for the next one, log of 16, oh, and no, I'm sorry. In the other calculator, so I have both of the calculators in here, it's a little bit different. In the other calculator, you press the log button. Okay, so so that you know your calculator might be a little bit different. Then you're gonna press the the fixed value, and close so it automatically has a parenthesis in here. You press the 256, which is the fixed value, and then you close the parenthesis, because it doesn't close it for you. You need to close the parenthesis. Then you press the divide by. Then you press the log again. Then press the base, and you close the parentheses, and finally press equal. Okay, if you notice, you still get a 2. So the process for both calculators is a little bit different, and it can be tricky if you're not familiar with them. So yeah, this is either this path or this path that you have to follow. Hopefully you don't have a different one that you might have to do something else. Okay, so let's see. We're gonna end up with decimals and fractions in here, and as I told you I'm gonna show you an easier way. But if you think about it, in here we have 16 is the same as, to make the base 2, you need to have as a root with index 4 of 16. Okay, so that's important that we know. Why? Because one number multiplied times itself 4 times equals 16. Well, 2 times 8, 2 times 4, 2 times 2. It tells me that I need 4 in a group, and I only get the captain of that group. Okay, so it's 2. So the root index 4 of 16 is equals to 2. Okay, and that's important because, again, as I mentioned, these numbers are in here, and that these come from base 2 with some exponent. So basically, we're going to need that information. So the answer for y in here is going to be 7 over 4. Why is that? Because the base is the same. Let me write it right next to it. The base is 16. If we take the index as 4, because remember we needed this base 2, and then we need to multiply, that becomes a 2, but then we need to multiply that to the 7th power, okay, meaning this whole thing is to the 7th power. Then we can say that 16 to the 7 over 4 will give me the 128. Why? Because we're taking the square root of 16 4 times. The index is 4, that's equals to 2. We raise that to the 7th power, and that's equals to 128. Okay? In decimal form, that would be 1.75, because it's 1 whole and 3/4. Now, what if we just put it in here, 128, okay, we're just following this path, press the log button, divided by 16, and then the log button again, and then equal, that's 1.75, okay, right there. The next one, I'm just gonna go directly to this. 64 log divided by 16 log equals 1.5. So my y will be 1.5. And if we think about it, it's saying that it's going to be 1 1/2, which is equals to 3/2. Okay, if we go on this path, using the first example, we know that the base is 2, so the denominator will be 4, okay? The denominator will be 4, and 2 to the what power equals 64? 2 to the 6th power, so the numerator will be 4. If we simplify that, both are divisible by 2, and so it's going to be 3 over 2. Okay, 3 over 2. If we divide 3 by 2, it's 1.5. Teacher, can we please go to the easy way now? Almost there, almost there. Okay, again, we already know that this gives me base 2 if I put the denominator 4, right? The index 4 gives me a 2, but 2 to what power equals to 32 to the 5th power. Okay, what this is saying is that I have the 4th root of 16 raised to the 5th power. Remember that this is the exponent, this is the index. Okay, the numerator is the exponent, the denominator is the index. And so it will be 1.25. Why? Because 4 goes into 5 once, and then you have 1 left, and 1/4. Let me just write it in here. 1 left over 4. So 1/4 is 0.25. If you use a calculator, 32 log divided by 16 log equals 1.25. Okay, and the last one, we know that this gives me, when I have the denominator 4, gives me a 2. 2 to what power? It gives me 2 to what power gives me 16. So it's right here. 2 to the 4th power is equals to 16. So that's going to be my exponent. And so we know that this gives me the 2, but then 2 to the 4th power equals to 16. And so 4 divided by 4 is 1. In decimal, it's going to be 1. Okay? You probably understood several parts of it. And okay, maybe I can just keep going and using it and using it and using it until I get it. But why if I can find an easier way? Okay? And so, I can't believe this. Oh, there it is. Okay. And so what's the easy way? Now, if I was to graph this information, let me move this out of the way. And again, it's just gonna be a sketch. This is just similar to what we've been doing. So when it says 256, it's talking about the x values. Y is your y values. So x and y, just like before, but now the bigger values are on x, the smaller values are on y. Okay, so let's say that my value for y is 1. My value for y is 1. For x is going to be 16. If my value of y is 2, my value for x is 256. So something like this. And if it's 0, 0, it's going to be 0. So my graph is going to be something like this. Okay? Now, have that in mind. But now, let's figure out what is that easy way to find these values. Okay? So, here it is, finally. Okay, so, you know how going from x to y was a little bit tricky because of all those involving of decimals and fractions? What I'm going to ask you to do, let's see, you have x, you have y, this is the fixed value, this is the exponent, right? 16 to what exponent is equals to 256, so that's what it means, basically. And so, to make it easy for you, instead of finding values that are going to be easy to find, like the 2 and the 1 was easier because they're whole numbers, what I'm going to have you do, and you're going to kill me for this, is that you're going to give values to y instead. Okay? So, you're going to give me 0 for the y, 1 for the y, 2, 3, 4. And so, when I'm talking about log base 16 to the x power, what it's saying is that 16 to what power is this value, right? Now it's going to be a lot easier because you already know the answer. 16 to what power? Well, this power is equals to this value. Okay, so that's going to be a lot easier because 16 to the 0 power is equals to 1. Let me fill this out with a different color. 1 to the, no, 1. 16 to what power equals, to 1 to the first power equals to what? 16. Do you see the difference between this and this? This is my answer that I was looking for, the 1. Now I'm choosing these values instead of having huge values and figuring out what is the exponent to get to those values. Okay? 16 to what power is something? No, it's more like 16 to the second power will give me that fixed value. 16 to the second power is going to give me what value? So it's going to be 16 to the second power equals 256. And we knew that already, right? Because we knew the answer for y when it was 256, the answer came out to be 2. 16 to the third power equals 4096. So see how it's easier, instead of getting the fixed values, you're choosing basically the answer of that logarithm. You're choosing those values and you find the fixed value to be able to graph it. 16 to the fourth power equals, and that's a huge number, 65,536. Okay, so that's going to be a lot easier to graph because you have the exponent of that base, which is going to be actually the answer, and now we'll be able to graph it. Okay. Again, it's going to be a sketch because we can't really go all the way to these huge values. Okay, so we're going to have 0, 1, 0, 1, no, 1, 0. So it's going to be 1, 0. It's right there. 1, and then you don't go up or down. Then 16, 1, you go up 1. Then 256, 2, 256, 2, maybe around here. And that's gonna be my graph. Okay, it's just a sketch because in reality this is 1, and so there are not 16 of these spaces in here, and there are not 256 spaces of this in here. Okay, so it's just a sketch. Okay, so did you find that easier? Just give values to the answers basically, and by raising 16 to that power you will get the fixed value. You will choose more beautiful numbers for this. Okay, now I can tell you, you work in the previous lesson, you work with inverses. Remember I told you that the inverse, when you found f of -1 of x, is the inverse. So we're gonna now find the inverse, because remember I told you that the mirror was here. If this graph is here, then the inverse will be here. I'm going to show you how logarithms are the inverse of powers. Okay? Okay, so if I have log base 4 of x equals, now remember we're gonna give values to the answer instead of giving values to that in here, okay, because we don't want to complicate our lives like we did with the first example. So we're gonna put the fixed value here, but instead of choosing that first, we're gonna put the exponent, meaning the log of 4. Okay, and so this is my x, this is my y. Again, we're gonna give values to x instead. So 0, 1, 2, 3, 4, and you can go farther, but I think I'm gonna stop at 4, especially since you can't really graph all of that. So f of x is gonna be 4 to the x. So this is basically the power. It's the inverse of this. Okay, so 4 to the power equals, and this is 4 to what power equals the x. Okay, so they're inverse of each other basically. And so this is x and this is y. So basically in here is the opposite. My x is the power. So power of 0, power of 1, power of 2, power of 3, and power of 4. I'm just going to go up to 4. So these are going to be exactly the same, but basically they switch the values for x and y. And so 4 to the 0, 1. 4 to the 1, 4. And so in here what it's saying is 4 to what power equals what number. And in here we're saying that 4 to the first power is going to be 4. Four to this power, which is my answer, is equals to the 4 in here. Okay, 4 to the second power, 4 times 4 is 16. And so in here it's just gonna switch. Okay, it means the log of 4, log base 4 of 16 is 2, meaning base 4 raised to the second power is 16. Okay, to the third power, 4 times 4 is 16, times 4 is 64. So I'm going to write down in here. And then finally, 64 times 4 is equals to 256. Okay, I'm not going to graph all of that all the way, but let's see. So if I have my graph like this, I have 1, 0. So 1 on x, 0 on y. 4 on x, 1 on y. That's for my logarithm. 16 on x, 2 on y. 64, and again that will go way outside of the page, so I'm not gonna do the exact. Let me see, can you see that? I did this a little too apart, and so I don't have enough space to have all of them show. Let me see if I can shorten this space between. So again, it's not going to be very accurate, but I'm trying to put it as much apart as I can. So 64, and in here is going to be 3. So my graph, or sketch of the graph, it's a little bit like this. It shouldn't be, should be more curvy, beautiful, but yours are going to be better than mine. Okay, now for the power with base 4, we have 0, 1, so 0, 1, 1, 4, so 1, 4, something like here, and then 2, 16, so maybe around here, 364, so 364, and that's probably, I mean, that should be higher up, but again, it's just a sketch, and so my graph would be something like this. Okay, again, that should be more beautiful, but as you can see, they're mirrors diagonally. Okay, there is like a mirror in here that is diagonal of y equals x. Okay, and this reflects with this point with a lot of imagination. This reflects this point, and this reflects this, and this reflects this point. Okay, so I hope that I didn't confuse you too much. The first one, the first example after the warm-up is just so that you are familiar with what the logarithms are, but you can most definitely use this simpler method, okay, where for the logs, you just give the values to y and raise this to this power. Okay, it's 4 to that power. 4 to the 0, the answer there. 4 to the 1, the answer there. 4 to the second power, that's the answer. 4 to the third power, 4 times 4 times 4, 64. And for the powers, is just f of x equals 4 to the x power. You're giving the same values to x, and so 4 to the 0, 1. 4 to the 1 is 4. 4 to the 2 is 16. 4 to the third power is 64, and so on. Okay, so use this method. Don't use this method because it gets a little too complex. Okay. Okay. Sorry that this video is a little longer than usual, and well, now you can work on 8.12.